I often get the question about design rules for Rheocasting. I will try to cover that by showing some applications which have been casted with Rheocasting. This is a filter for telecom. And what's interesting here is the air that can be divided by the walls. So the wall thicknesses are of interest for the customer. Here we have succeeded to cast the walls with 0.4 millimeter wall thickness with 1 degree draft angle per side. This is fully possible with Rheocasting. However, if this would be in serial production, we would recommend to have an average thickness of 0.8 millimeter in order to increase the yield. This is another example of a filter for telecom. Conventional casting, you make a raw casting, you machine the hole, and you mill all the heights. With Rheocasting, it is possible to go directly for the final version. Here we have casted the holes, we have casted all the heights, which means that we can save a lot of machining cost. This is another example of what we can do with Rheocasting. Here we go totally opposite, thick walls. The purpose with this is to replace iron with aluminum. With Rheocasting we can cast the part in such a way so it's possible to do heat treatment. This part has been T6'd, heat solution treatment, and heat aged. Another application that has proven to work very well with Rheocasting is pressure tight parts. Due to the solid traction we have in our material, we're able to cast with very, very low porosity. That means that we can cast directly components that require pressure tightness. And in this case, we have been able to remove all impregnation. So pressure tight applications is a very good application for Rheocasting. Another application where Rheocasting have proven its abilities is within heat sinks. Here we are able to cast very complex geometries in an alloy with only 3% silicon. That allows us to enhance the heat conductivity up to 180 watts per meter Kelvin in as cast state. And 105 millimeter high fins with a draft angle of 0.6 degrees per side, also casted in an 800-ton machine. The requirement for heat sinks are that they are growing and growing as well. Here we are able, due to Rheocasting, to weld 2 heat sinks together. And this is due to the low microporosity content inside the material, which enables to make a very large casting in a very small machine. Lost cores, that has been talked about very much in our business. With Rheocasting, due to the lower pressure, we are able to use conventional sand cores to cast impossible geometries. Here's one example where we have casted a faucet. So, that's a compilation of the applications we have casted so far. We believe that we have only found 10 to 15% of the ability of Rheocasting. All parts you have seen has been maximum casted in a size machine of 800 tons, which means that this part, for instance, 19 kilos shot weight in 800-ton machines. Imagine what bigger machines can do for the future.